Good morning, everyone. So, my name is Renee. I'm new to YouTube. I decided to make this YouTube channel about interesting facts, stories, anything. It started out after I was talking to this one German guy, and he was asking me about this one little bird, small bird, well, maybe a bit more like this. They didn't have this bird in Germany, and he asked me about it, and it got me thinking. This is such a common thing to ask. How many interesting subjects are out there that I don't know about? So I want to share this experience with you guys, and I decided to do my first take on black holes. Now, every week will be different. It won't just be space related stuff, it might be animals, it might be sports, indigenous sports to different countries. So, I'll see how it goes. If you like this video, please subscribe so you can see my other videos. Please also comment on if I miss certain stuff in a topic. I am not an expert on this stuff, so it might help if you guys know more about it and give me interesting topics you would like me to see. Maybe it's something I know, maybe not. That's the entire point of this channel. So let's start. Now, a black hole are a quite common object in space, even though it sounds very like, "Whoa, they are so dangerous, they suck everything up." But it's turned out they are not that far and distant from each other. They are everywhere, but they can be from small-ish, low mass black holes. It might even have microscopic black holes, but I'm not sure how far that research or upon that. As far as I know, it won't be easy to actually detect them. Even medium-sized black holes by the mass of the sun, up to 10 solar masses, even they, if they are not next to um, a star or a neutron star, we cannot even detect them, since you need a object that you can actually see. We cannot see the black hole, so if he's not orbiting anything, we won't see him. So you need a star that's orbiting something. You cannot see the companion. Work out a bit of math, and then you can determine it should be a black hole, depending on the theory. And then they go up there. They are said to be intermediate black hole sizes, few hundred solar masses at the center of dwarf galaxies, maybe even globular clusters. But that's all just theory. I'm not quite sure they have proven that yet. But going to even bigger supermassive black holes, you get galaxies. They are at usually, well, we are quite sure these days that they are at the center of a galaxy. So the entire galaxy rotates around the black hole, kind of like a whirlpool, sucking everything in. So they are dangerous in the fact that if you go to them and you pass the event horizon, we'll hold your funeral so long. But it is plausible, at least according to theory, that you can pass the event horizon without dying. You'll have pain because of what's known as spaghettification. If you are, here's the black hole, here you come. So your feet are closer than your head. There's your head, there's your feet, there's a black hole. So that one is closer to the black hole than your head. So according to gravity force, this one your feet experience much more gravity than your head. So you are being pulled like, and you form a spaghetti. um, and furthermore, as you'll come closer and closer, it will seem if everyone else is going crazy, they will start speeding up due to time dilation. Everything will start happening very fast, but that's just because time gets slowed down here. So normal speed for you, everything hit your eyes at rapid speed after they were slowed down and compressed. While for us on the other side, we'll see you slower, slower, slower until you stop. You effectively will go faster for you and you'll go slower for us. We'll also see you being redshifted. So you'll be normal color, and as you get closer to the black hole, you'll turn more red, more red, more red until you start going into infrared radio waves, because your waves will be stretched or contracted depending on relative to who you're looking at. But so we'll see you redshifted. Then, if you go past the event horizon, goodbye. The event horizon is the actual disk we are seeing. If we look at a black hole, we see this black disk, but that's not the black hole. The black hole is the singularity inside the disk, like in the middle of the disk. The event horizon is just the part where gravity is so strong nothing can escape. That not even light. That's why it appears black, because nothing gets released. Then, so inside is the singularity, outside is the event horizon, the point of no return. So if you're that side, you stay that side, we stay that side. Effectively, there's another event horizon called, namely the observable universe and the size of the universe. The size of the universe is much bigger than the observable universe. But we cannot see what's on the other side because of light constriction. We have to wait each day for light to go a bit further, going on. So event horizon is a big part of the black hole, and they can vary in sizes. They have it's the Schwarzschild radius, and it depends on the mass of the black hole. After that, inside the black hole, you'll have everything. Inside there, you'll see the beginning of the universe. You'll see the universe growing, evolving. You'll see the end of the universe. You'll be in the prime seat to see all of that. That's because inside, everything just falls inside, cannot come out. So the light from the beginning of the universe is still inside the black hole. You fall in so you can see them, and if you look back, you can see all the new light from the universe as it's passing, speeding up, like I told you. You'll see that at the back of you. It's quite interesting, actually. So for one moment, you'll be in the best museum in the world. You'll have stories no one can even imagine. But yeah, that's my take on black holes. Surprisingly, another thing about them, black holes are the the trophy, you can say, where gravity won. They could say we won. Because it's since the beginning of the universe until the end of the universe, it's a constant battle between gravity and everything else. Pressure going outwards, keeping a star in a ball form. Dark energy, another term for another day, pushing out, taking the universe big size. Even us here on the planet, we are building rockets to take us into space so we can get out of this gravitational field. Everything tries to stop gravity, and a black hole is where gravity won. They can finally say, yeah. But even though you would think gravity being such a strong dominant force, they are not the strongest force out there. They are they are four, and they are literally the weakest between the four fundamental forces. So there's this philosophical question: why does gravity dominate? I mean, it's not very special, so why does it dominate? But it has to do with the fact that gravity is a universal force. It has no real range, whereas the other forces, two of them, the strong force and the strong nuclear force and the weak nuclear force, actually have a limit, while electromagnetic force has a limit, but they are a small charge compared to a massive mass, because charge and mass, if you go look up, are actually um, similar. If you take electrical charge current, it's q squared over 4 pi epsilon 0 r squared, where the 4 pi epsilon is just constant. And for mass, it's g m squared over r squared, with the m not being literally the same m, but more mass of the one, mass of the other one, and same with the q squared charge of the one, charge of the other one. So even the forces are similar. So if you have a massive mass, small charge, which are equivalent in this case, the gravity will win, but electromagnetic force on a small scale is stronger. So yeah, thank you. Let me know what you think about this video, and I'll see what I can do for next one.